Hello friends, in this video lecture series I'll be talking about rules for aromaticity, or how we can apply these rules to identify which compound is aromatic or not. In rule number 1 we discussed that every compound, if it has to be aromatic, it must be cyclic in nature. If it is not cyclic, then the debate is over. It cannot be aromatic. Okay, now let's have a discuss about the rule number 2, or condition 2, which says every atom in the ring must be conjugated, or let me put it in another way, every atom must be sp2 hybridized carbon, or let me rephrase it again, every atom must not be sp3 carbon. Okay, so every atom should be sp2 hybridized, or every atom must be conjugated. All right, so what is conjugation? Let's have a look at this benzene example. All of these 3 pi bonds are alternating between one atom to another. There are 6 carbons in this ring, and there is a conjugation between these 6 carbon atoms, and they are conjugated with each other, and there's alternating pi bonds between these carbons. So this system is fully conjugated. And if you look at a slightly different example than benzene, this is a cyclohexadiene, but this compound does not have all carbons sp2 hybridized. Some of them are sp2 and one is sp3, which is this one, cornered one. This is sp3, and these double bonds are in conjugation to each other, but it's not a fully conjugated system. As you can see, there's a contrast between benzene and this cyclohexadiene. So this is how you identify which compound is in conjugation or not. If it is in conjugation, if it is in cyclic, that's going to be aromatic. But that's not all. We have 2 more rules to identify aromaticity, but for the sake of this video I'm only talking about rule number 2. But in the next video I'll be talking about rule number 3, and in the next I'll be talking about rule number 4. So there are 4 total rules. If any compounds obeys all of these 4 rules, then it is going to be aromatic. If it obeys rule number 1, if it obeys rule number 2, if it obeys rule number 3, and if it does not obey rule number 4, it's not going to be aromatic. It must obey all of these 4 rules. So let's understand the rule number 2. So we cannot only decide on rule number 2, but we have to understand all the rules in order to understand which compound is going to be more aromatic. So this ring, which is a Phenol ring, and there's a cyclic compound, rule number 1 is obeyed, and the system is in conjugation. As you can see, the lone pair of this nitrogen are fully involved in the whole ring, and they are in resonance to each other, and every carbon is sp2. There are 4 carbons in this ring, and every carbon is sp2 hybridized. All good. That's why this is aromatic. All ring atoms conjugated. If you look at this compound, when you have a methyl with this nitrogen and proton on this, so there are no free lone pairs available on this nitrogen. Now this compound is cyclic. Rule number 1 is obeyed, but this compound is in conjugation. No, it's not, because this nitrogen does not involve any conjugated atoms. So hence this is not aromatic, even though it satisfies the 2 rules, which is the compound must be cyclic, compound must have sp2 hybridized all carbons, but it does not satisfy the conjugation concept, hence it's not aromatic. If you look at this compound again, which is slightly different than this, we are replacing nitrogen with carbon, and that carbon carries a negative charge that is called carbanion. Now if you see, the lone pair of this carbon are involved in resonance, they are in conjugated system, hence it's called aromatic, because it obeys rule number 1, which says it must be cyclic, and rule number 2 which says it must be conjugated, hence it is aromatic. If you look at the slightly different example where we have a methyl group instead of negative charge, now this carbon does not have any free lone pairs, because carbon can make maximum 4 bonds, and it has already made 4 bonds. It does not have any free lone pairs, hence this carbon is not involved in any conjugation, or it's not conjugated carbon, it's not sp2 carbon, hence it's not aromatic. So the key point in this compound is this carbon is not sp2. Every carbon in whole molecule must be sp2, then we can say it's aromatic. So hence this is not aromatic, because carbon is not conjugated or it's sp3 hybridized. Have a look at this phenol If you look at this phenol, the lone pair of this oxygen or the benzene ring is fully conjugated. All ring atoms are conjugated. If you look at this slightly different example than phenol, this is a ketone, cyclic ketone, but with a conjugated dienes. But if you look at this carbon, which contains 2 hydrogens, hence this carbon has sp3 hybridization, or this carbon is not involved in resonance, or this carbon is not involved in conjugation, hence it's not aromatic. If you look at this example, we have a cyclopropene, double bond inside the cyclopropane ring, and a cationic form on this carbon. So it's a cationic form of cyclopropene. It's a cyclic compound. It obeys the rule number 1. Rule number 2 is every atom must be sp2 hybridized, and all of these carbons are sp2 hybridized. And rule number 2 also says, in other words, it should be conjugated, it must be conjugated, hence this double bond is delocalized over other 3 carbons, hence all ring atoms are conjugated. That's why it's aromatic. But if you look at this compound where we do not have any positive charge on this cyclopropene ring, there's a CH2 unit which is sp3 hybridized, hence it's not aromatic. So this is how we apply this rule to identify which compound is going to be aromatic or not. So I hope rule number 2 will help you to understand aromaticity, but this is a clear warning: do not decide only on rule number 1 or only on rule number 2. You have to apply all of these 4 rules. I'll make another video where I will discuss the rule number 3, which will help you to understand how to identify which compound is aromatic or not. I hope you like this video. Please subscribe and share it with your friends. Thank you.